Hello, today we're going to be talking about section 4.5, which is on proving triangles congruent using angle side angle and angle angle side. So we've already talked about what's called an included angle, and so the opposite would be an included side. It's the side located between two consecutive angles. So if we have angle A and angle C, AC would be considered the included side. So we have what's called the angle side angle congruence. And so what that says is if I have an angle, let's say angle B is congruent to angle E, and I have a side, BA is congruent to ED, and then I have another angle A here is congruent to angle D, that means that my triangle is going to be congruent. Angle, side, angle. Angle, side, angle. So let's write a two-column proof of this right here. It says, given that QS bisects angle PQR, so here's PQR, so this bisects, that means that this angle is the same as this angle, and PS is PSQ, so PSQ would be right here, is congruent to RSQ, which would be here. Prove that triangle PQS is congruent to triangle RQS. Alright, well first, just like in yours, we have it given that all that information is given to us, that QS bisects angle PQR and PSQ is congruent to RSQ. Alright, so the next thing we can say is that triangle, or that angle PQS is congruent to RQS, and that's based on, I already proved it in mine, or already showed it in mine, but that's because that's the definition of angle bisected. When you have something bisect an angle, it means that the two angles are equal. Now the next thing it says is that QS is congruent to QS. Well, that's just the reflexive property. We already know that anything is congruent to itself. And so now if I look right here, I have an angle side angle congruent to an angle side angle in another triangle. That means that by angle side angle, ASA, these triangles are going to be congruent. If you'd like, you can try this example right here, pause the video and try it, and we can talk about it tomorrow. Now, another one that we have is called angle side congruence. So that's when you say an angle is like B is congruent to E, and then right next to it I have A congruent to D, and then the side that corresponds right across from this angle right here, if those are congruent as well, that means my whole triangle has to be congruent. And if you're interested in seeing how that goes, here's the proof of it. So we know that L right here, L is congruent to Q. And we know that M is congruent to R. And we know that these sides right here are congruent. So let's look at the proof. Okay? So according to the third angle theorem, if you know that two angles are congruent to two angles in another triangle, the third angles have to be congruent. Okay? Third angles have to be congruent by the third angle theorem. And then now we're looking right there, and we say, okay, well, if we know that two angles, or all three angles are congruent, and one of the sides is congruent, that means all the other sides have to be congruent. And so by angle side right here, these triangles are going to be congruent. Alright, so we have to write a two-column proof proving why these triangles ACD is congruent to ECB. Okay, here's my proof. Okay, so the first thing I'm going to say, it says that DAC, so DAC right here, is congruent to BEC. Okay, so those angles are congruent right there. We also know that side DC is congruent to side BC. Okay? So we know those sides are congruent to each other. And what we're trying to prove is that ACD, this whole side right here in blue, is congruent to ECB. So if you look at our triangle, it's this side of my black triangle and the bottom side of my blue triangle that are going to be congruent. So that's what we're looking at right there. Okay? So, alright, so the first thing that DAC is congruent to BEC, okay? And DC is congruent to BC. Okay? That's my given information. That's given. Now the next thing we want, if we're going to use angle, we could do angle, angle, side. We'd have to see that angle C is the same in both of them. Well, the nice thing is that angle C is going to be congruent to itself, and that's the reflexive property. Okay? So now I have an angle, 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 side is congruent to angle, angle, side. And so we can say that these triangles, ACD, is congruent to ECB by angle, angle, side. Box it, and we're done. Example 3. Jeremias is working with a community service group to build a bridge across a creek at a local park. The bridge will span the creek between points C and B. Jeremias located a fixed point D to use as a reference point so that the segments have a relationship shown. A is the midpoint of CD and DE is 15 feet. How long does the bridge need to be? Alright, so first I'm going to see that angle B here is the same as angle C. Okay? So if we can prove that these triangles, if this triangle right here is the same as this triangle right here, then if this is 15 feet, this side right here is going to also have to be 15 feet. But we need to prove that the triangles are congruent. So first, like I just said, D is congruent to angle C. They're both 90 degrees. Now the next thing I can say is that this angle right here that is made up there are going to be congruent. Why are they congruent? Because they're vertical angles. Okay? And then it says that CD is cut in half by angle or point A. So that means that AD is congruent to AC. And we know that angle D is congruent to angle C. And we know that this made up angle, which would be angle DAE, is going to be congruent to angle CAB. So we have an angle, side, angle. So by angle, side, angle, those triangles are congruent. So if DE is 15 feet, how long is BC going to be? 15 feet is my answer. Here's another example of a guided practice problem that you could use to find the missing side and to prove that they are congruent. So, what are our 4 types of postulates that we can use to prove triangles are congruent? We have the side postulate. If all 3 sides are congruent to all 3 sides of another triangle, that means that the triangles are congruent. We have the side angle side. So if we know a side angle and then a side are congruent to a side angle and a side in a triangle, that would mean that they are going to be congruent. Today we talked about angle, side, angle. So if angle, side, angle are congruent in 2 triangles, that would mean the triangles altogether are going to be congruent. And finally, we also have angle, angle, side, angle, angle, side. So that would be when we have two angles and the non-included side on the opposite side.